Hi guys, we're beginning a very new topic for you, I know, but it's not really complicated at all. If we keep on thinking about fractions, decimals, percents, and now we're going to add something else to this idea of relating these three things. That is, how do we deal with random? Now remember, the word random tells us that how something happens when we don't expect it, right? So what we want to think about here in probability is pretty much the study of how random events occur. What we want to think about here is, what is the chance for any situation to happen? And we are going to measure that chance. How do we measure it? It's always going to be in terms of understanding what is the big picture of everything and what is the one thing we want to look at specifically. Always paying attention to all the options we have. Now, in probability, we gotta keep in mind certain new terms so we understand what's going on, all right? Think about experiment. Of course, in science, that means something. But here in probability, an experiment is a procedure that we can just keep on doing and doing and doing. And it can be endless, right? That's why it says infinitely repeated. And it has a well-defined set of possibilities. That means that whatever I'm doing, I actually have options before I know what the answer or the result's gonna be. For instance, when you roll a die. If you roll a die, you take the die, and you know, it's either 1, 2, 3, 4, 5, or 6, right? Or if you have a spinner, then that spinner is going to have certain sections where the arrow is going to land, right? Or if we have the regular spinner we used to play with when we were younger, then it's just going to fall into one section, right? So we have different types of experiments. We also can have a bag with different marbles inside, and then we can decide how many marbles I'm going to take out, and we can actually take marbles out and put them back in infinitely, right? That's what an experiment is. Then experiments have results, just as I was telling you, and we call them outcomes. So if I rolled a die and it landed on a 3, that 3 is one result I get. One of infinite results I can get. Because if I keep rolling the die, it's going to be infinite, right? We, in probability, don't call it result very often. We actually say outcome. So that's a word that we're going to hear and read very often in chapter 19. And then sample space is nothing but actually all the possible outcomes in an experiment. It's a list or a set of results we can get. In the case of the die, we're gonna have either 1, 2, 3, 4, 5, or 6, right? So think about here, we have our die over here, right? And so think about 1, and then probably 2 here, and then probably, I don't know, 5 here? I don't really know the setting of a die, but think about this die. Okay? Now, we usually write it down this way. S as for sample space. This S is gonna be sample space. And we get the braces. Remember, we used to use them for pandas? Okay, we use them here too. So the sample space again is all the possible outcomes. So for the die here is going to be 1 or 2 or 3 or 4 or 5 or 6. Okay? Now think about a coin. If I have a coin, I don't know. Sorry, I'm really bad at think about that as a coin. Sorry. Let's just think about that as a coin, all right? What is going to be my sample space? we're gonna have heads or tails. We cannot have any other option. Now, heads in Spanish usually is cara, and tails is sello. All right? Think about those. Now, we can have sample spaces depending on experiment. So if I actually mix these two, then I can have a different sample space. If I throw a die and then I roll, if I throw a die or I roll a die and then I throw a coin, then I'm just gonna have a mix of that. And that's why we actually need different ways to represent the sample space. We can have grids, we can have tree diagrams, or we can just have a list like this but combined. What if we are throwing a die and a coin at the same time? What we need to keep in mind is what is going to be the sample space for this experiment, right? I have the 6 options for the die. How are the options for the coin going to work? Well, if I'm throwing both at the same time and I get one in the die, there are 2 options I could get the coin, right? We can have heads or tails. So we can just say heads or tails. This way, see? And so that it's gonna be the sample space. All right, now if I wanna make it a list, well, my list is gonna be this one. That's another option. So this is the tree diagram. This is what we call the tree diagram. All right, this is what we call the list. This is a list or a set. Now I know the book shows a different list, but it works. It also works. Now let's think about the grid. How am I going to work with the grid? And so that's our sample space as well. This one we call it the grid. So we have 3 options to represent the sample space. What really is important, guys, is to actually know how to distribute the 2 things or the objects we're working with the experiment for, okay? I'm going to show you here how to represent the sample space when I'm going to throw not only 1 coin but 3 coins. How is that gonna work? Well, I have a first coin here, right? That first coin has 2 options, heads or tails. Now I have a second coin here. That second coin also has 2 options, but remember, it depends on the first coin. So here I'm gonna have heads or tails, and here I'm gonna have heads or tails. Then I'm gonna have the third coin. And the third coin again is going to depend on what happens with the second and what happens with the first. So I need to get heads or tails here, but also here. Do you see it? And then if I want to think about the list, I mean, this is the sample space. This is the tree diagram for the sample space. But if I want to make a list, then I probably am going to get heads, heads, and heads, then heads, heads, and tails, heads, tails, and heads, heads, tails, and tails, tails, heads, and heads, tails, heads, and tails, 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 and heads, and finally, all tails. So that is going to be my list. See? All of these options, we have them when we want to represent the sample space. This is going to be my sample space. Out of this representation, we can actually say, okay, what are the chances to get only heads? Well, I can. There is only 1 option here to get heads in all 3 coins. Out of how many options? 1, 2, 3, 4, 5, 6, 7, 8. So I know I'm going to have 1 out of 8 options that is going to be all heads, right? But that's for lesson 2. Don't worry about it right now. Now, I'm going to do number 1 with you so you get to see it in terms of the exercises you have in the lesson, right? The sample space here, for me, it's a lot easier to do the tree diagram first, just because I'm actually very visual, and so I'm able to see it that way. So what I'm probably going to do is I'm going to think about sections A, B, and C, and then I'm going to get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Can I do it the opposite way? Sure. It's not a problem. You can actually do it the opposite way and you're going to get the same amount of possible options. Okay? So what is really important is that I'm actually getting 18 options here and I'm getting 18 options here. I need to see that all the time. I need to see how many options do I get in the sample space. Okay? Now, do I want to do the list or the grid? Sure. Again, same thing. A, B, and C. And then 1, 2, 3, 4, 5, and 6. And you work it out the same way. Okay? Let's think about what is the sample space when I throw 2 dice. If I want to roll 2 dice, what would be the sample space? Well, I'm not gonna do it all because it probably is a whole lot of work. And this one is probably better to do the grid. So what I'm gonna do here, and if I ask you this, you're probably gonna say 12 because we have 6 options on one die and then we have 6 options on the other die. And as you have noticed already, if I multiply the options I have in each one of them, I get the amount of possible combinations, right? So 3 options in the spinner, 6 options in the die gets me 18 options, right? Or 2 options on the coin and 6 options in the die gets me 12 options. Or if I'm throwing the coin, 3 coins at the same time, I have 2 options on the first one, 2 options on the second one, and 2 options in the third one. So 2 times 2 times 2 is actually 8. We can multiply the options we have in each one of the objects, and then we're going to get the amount of possible outcomes. That means the number for the sample space. Now, all the combinations, we definitely have to use tree diagram or the grid or the list. So if you get me, well, if I'm throwing 2 dice and I'm rolling them out, that means I'm going to get 6 options on one die and 6 options on the other. A lot of times I've got people saying, oh, so that's a total of 12. But as we just talked about it, we should be multiplying the options, right? So that would be a total of 36. But how do we see it? Well, think about 1, 2, 3, 4, 5, and 6 on one die, right? And then 1, 2, 3, 4, 5, and 6 on the other die. And so the grid is actually going to end up with 36 options, which of course is going to end here with 6,6. That's probably going to be the last one, right? So think about that. Every time you want to know the amount of combinations, it's just a matter of multiplying the possible options I have in each one of the objects. That takes us to the fundamental counting principle. That's what you gotta do all the time. You have to multiply the options you have in each to get the amount of possible combinations. Sometimes it's easy to do the tree diagram for one of those. Sometimes it really is not easy at all. Okay? Just think about the options you have. Like if you want to get ice cream and you have flavors. You can have, we're going to get ice cream. We have these options, right? We have cone or we have a cup. Then we have actually 2 options of flavors. We have vanilla and chocolate, right? And then toppings, we can have a crack. We can have a cracker, right? We can also have chocolate chips, or we can have a cherry. And so we actually get those three options here, right? 1, 2, 3, and 1, 2, 3. And so, question is, how many options do we get at the end? Well, think about it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The very last branch in the tree is going to tell me how many options I have available. Now, the fundamental counting principle could have just said, you know what? I'm going to do this. 2 options for cup or cone. Then 2 options for the flavor. And then 3 options for the toppings. So that's a total of 12 options. See? So the fundamental counting principle is going to help you dealing with it a lot. The problems I want to work with you, I will work with problem 14, which says, in Nigeria, people play the game Ikfata, which means to pitch and toss. In the game, players tossed 4 shells. So shells could land opening up or opening down. How many possible outcomes of tossing 4 shells are there? So guys, to work in this problem, we're going to do the same as we did it with the coins. We have 4 shells. Now we have 2 options. They got to land up or they got to land down. Let's go with the second one. Here, you know what, I'm going to put this one a little bit farther down. And so here's going to be up and down. And the same here. Then third. That's a lot of work, isn't it? Yeah, it is a lot of work. How can I save a little bit of time? Yes. You gotta use the fundamental counting principle. And I'll show you how. Down, up and down, up and down. So the fundamental counting principle is gonna be just, you know what? I have 2 options in the first shelf. Then 2 options in the second, 2 in the third, and 2 in the fourth. That ends up in 16. Now count the last branches in each one of the rows we have in the tree, and we will see there's also 16. That is, of course, going to be faster with the fundamental counting principle. Of course, when I ask you to make a tree diagram, well, you got to make it. But if you can save time, sure. Use fundamental counting principle, that works. All right? Okay, well, this lesson is pretty simple. We're just getting to know what probability is and how to represent experiments. In the next lesson, we're just going to be working with sample space a little bit more in terms of numbers and how can we give a number to the chance for something to happen. All right? Okay, so I'll see you later.